So today we're going to talk about friction, and by definition, friction is a force that opposes motion. But before you would necessarily write that down, maybe you want to write it in terms of its three forms. We have three different types of friction. We see kinetic friction, we see static friction, and we see rolling friction. And those are the three types we're going to talk about today. And I'll try to give you some examples of them. So if we start with, I think probably it makes the most sense to start with static friction. And remember, friction is a force that opposes motion. So static friction by definition would be a force that opposes motion. And it's from objects that are not moving or locked into place. So again, if we're looking at static friction, this is a force from objects that oppose a static friction would be a force that opposes motion from objects that are not moving or locked into place. And to try to give you an example of what that might look like, if we could think about a surface. And now if you take a surface such as, a block of wood, or some plastic, perhaps even a styrofoam plate. If you zoomed in on any of these surfaces, you have to think about zooming in on them. You would find that surface is kind of like this blue thing here. This would be in cross section. That surface is actually kind of bumpy. Now, if we zoomed in, these surfaces might be different. You might have a surface like this. Surfaces could all be all kinds of different things, and it's going to be controlled by the material makeup and different things. But that surface would be kind of bumpy. And then if you have another material, such as this white one, it's going to be bumpy too. And now this is basically a caricature of what happens. But if you think about it, when something is sitting and not moving, it's almost like those irregularities in those bumps. They sort of lock together. Now, this is obviously a perfect fit. It wouldn't ever be, but depending on the materials, they sort of lock together. And that initial locking that objects have when they're sitting there, and the resistance to get started moving, that initial locked in place, that's what's called static friction. Now, once something's up and kind of bumping along and sliding, it's easier to keep it going. The friction is actually a lot less. And so that's called kinetic friction. And so another example of kinetic friction is once it's moving. And of course, friction is, as already mentioned, friction is a force that opposes motion. And this kinetic friction is caused from sliding or moving. And so what that might look like here, you can even think about like this little post-it note. Things are just kind of like skating along here as it goes along. And so this, as it's skating along here, there is a resistance pushing this way, but it's not going to be as bad as if this gets locked into place and these things lock. Once it's locked in, that would be static. Once it's moving along, it would be sliding. A classic example of this would be if you happen to be trying to stand up on say a really steep hillside. Well, when you're standing still, your shoes, you're not sliding yet, so you're taking advantage of that static friction where your shoes are locked in place, you're not sliding yet. We all kind of have a sense of if you're standing on a hill, once you start sliding, pardon the pun, it can be all downhill from there. And so once you would start sliding, well, then it's going to be kinetic friction, and that's less of a force. So it's one of those deals where once you start sliding, you actually are in more trouble. The similar thing I've personally experienced on roofs of houses, where once you start sliding, you are in serious trouble. The final source of friction we're going to talk about is rolling friction. This one's a little bit harder to really conceptualize, but it's worth talking about because it's something we see. And so rolling friction, of course, friction is a force that opposes motion, and it is from objects that are rolling. No, not that kind of rolling, not the eye roll. An example of what that might look like would be if we just had ourselves, and you imagine you're looking at this from the side. This is, pretend that this piece of wood here is the ground, and if we had an object such as this tape, imagine this is rolling along the ground. What's actually happening as it rolls is it's kind of like a little piece of this is getting lifted up, and then it moves forward, and then it sits down, and then it lifts up. So the whole time an object is rolling, really the source of friction is coming from the attraction between these two materials when they touch and then pull apart. So if we would go back to our model with our little pieces of paper, it's kind of like it's touching and then it's pulling apart. It's touching and it's pulling apart, and that happens constantly because of as it's rolling along. It's kind of like if you could think of this as a really bumpy surface, and then if you had a tennis ball rolling, you could imagine the threads of the tennis ball interacting and resisting the rolling, and or if you imagine a bowling ball trying to roll across a carpeted floor, the bowling ball's depressing it, and then there's just this interaction of constantly touching and pulling up and touching and pulling up. That would be an example of rolling friction. Another component of that is if there's enough pressure on it, this material would be slightly deforming and becoming flat and then going back together, and of course that would be warming up. You'll see that in tires and that kind of thing. It's a little bit more difficult to really frame everything that's happening, but we do find rolling friction to be very oftentimes, not near as much, obviously. Thank you for these notes, and I hope you have a great day.